God, Eric started us off already. Good morning, everybody. How we doing? Say hi. Hi. Look, I shaved. Mrs. Noah said I had to shave. So my Corona beard is gone. Who's here? 2 people. Gotta be more than that. How many people? Let me look at the stats. There you go. All right. So, hope everybody's doing okay. Here's a few informational stuff. One, the Monday. Remember, Monday is an institute day. They're going to teach us how to do e-learning. So on Monday, there's no new assignment. So don't be all sad if you're like, where's the assignment? So Tuesday, Wednesday, Thursday, Friday next week. And then we have another week. And then the AP test. Okay? So this week and next week and the following week are the last 2 full weeks of working on this stuff. Let me know. A couple people sent some messages already, but let me know how you felt that AP problem was. I kind of liked it. I like seeing you guys. I like talking to you guys. Hopefully we'll have more people show up. If a good time to do it, I would think maybe a good time to do it is right now. Maybe we'll do an AP problem at 8:30 because you have to be here at 8:30, or you should be here at 8:30. This is regular class time, so get up, wake your friends up. 8:30. But what did you think about that? Hopefully that helped out a few people. If you did not participate in that, we're going to do a couple next week. So here's how it worked. Remember, I post a problem up, and then you'll have the set amount of time. 25 minutes for the bigger problem, 15 minutes for the smaller problem, and then we'll go over it. And maybe, let's see. I'll see how many problems I can come up with. Maybe we'll do something like that definitely the following week, maybe once a day or something like that, just to practice. So we'll see. We'll see how that goes. So let's do something like that. And let me know. Send me a message. Now, if you did not participate in that, I still have the AP problem up there. So why don't you give yourself 25 minutes, print out the problem, give yourself 25 minutes, do the problem, and then the answers are up there also, and you could check the answers and to see how you did. But it's nice to go over it all together. So maybe next week, 1 or 2 times, we'll Zoom. We'll figure it out. This week's assignment, just to refresh your memory, take a look. This week's assignment. You had to do all 3 of these. We have to have a grade every day. So the 5 grades this week will be these problem sets. You got to do these problem sets, those 3 problem sets there. And then the other 2 is, one, you have to email me the questions that you have. Some people, I answered questions directly. Everybody else said, let's just answer, do this problem in the morning. And then you have to check your answers. And so there's you don't have to do anything for that. If you checked your answers, there's a key that shows me that you have opened up the answer document, and that's good for me that you've checked your answers. Remember, you got to say to yourself, this is your AP test. If it's to be, it's up to me. You have to be doing this. You have to be participating in it, and don't think some miracle is going to happen on May 12th. If you're not sticking with this, you're just getting rusty. So the next 2 weeks, you should commit to yourself to really, 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 being here, being ready to go, and we'll keep practicing these problems on it. All right. So let's make sure I'm covering all my material. People, first person emailed and said they want to go over. Let's take a look. I had it posted up here. They wanted to talk about, not that one. There it is. Take a look. So we're going to start going over number 7. Okay, take a look over here and let me know. It says a function is a table. This time we had a table of information right up there. This is number 7 on 6.7. And they gave you a table of information. Okay, and then it says the derivative is all the second derivative, blah, blah, blah. Evaluate the integral from 0 to 1.5, right? I got to zoom in on that. The integral from 1.5, show your work that led to the conclusion. Because some people were having a little trouble going through the properties. Okay, so let's try that one. Okay, we want to evaluate the integral from 0 to 1.5 of 3 f prime of x plus 4 dx. And let's review the properties of what we're doing. The first thing I'm going to do is I'm going to separate this whole thing. Okay, I'm going to separate them. I'm going to move across, and I'm going to say, all right, I could write this as 3 on the outside, the integral from 0 to 1.5 of f prime of x dx, plus the integral from 0 to 1.5 of 4 dx. Especially, and I'm thinking the AP is going to do something like this, especially when you have a function mixed in, it's best to clean everything up. You know, that's your first instinct should be not to just brute force your way through it, is to be, how can I clean this up? How can I make this a little nicer? Okay? So now, this integral hopefully is pretty easy. Can I think of a function? Can I think of a function whose derivative is whose derivative is 4? Yeah, I can think of a function whose derivative is 4x. So this one is 4x evaluated from 1.5 to 0. Plug in 1.5. I get, what do I get? 6 minus 0. So that's 6. You see that? Because remember, it's constant, so the antiderivative or the integral is linear. Now this one, can I think of a function whose derivative is f prime? Now remember, when the two different fundamental theorems, I guarantee, I would bet, if I was a betting man, I would bet that they're going to have these type of problems on your test, because the derivative and integral of derivative, fundamental theorem of calculus has got to be there. Okay, so can I think of a function whose derivative is f prime? Sure I can. F of x. There's a 3 in front, and that's still evaluated from 1.5 to 0. So this is 3, I'll use parentheses, f of 1.5 minus f of 0. Remember, if you didn't get this before, let's see how you're doing. Just plugged in, just like I did this one. Plugged in 1.5, plugged in 0. Well, where am I going to get that information from? I'm going to go to the table. F of 1.5, read your table correctly, is negative 1. So it's 3, negative 1, minus f of 0 is negative 7. All right, so what do we got there? This is plus. Let me copy the plus down. We got 6, 18, 24. There's your answer for that one. Okay, so if you were a little stuck last time, if you're still stuck, you gotta say something. How did we feel there? How does that look right there? Notice here's the main thing. Okay, the most important thing right here is cleaning it up, making it easier to look at. Okay, and then how do we integrate? Can you think of a function? Remember, we should have a little poster in front of you. Can I think of a function whose derivative is? That's the first step. Second step is anti-power rule and then anti-chain rule. Those are the ways we're going to integrate it. So you got to go through that. But notice, it gets too complicated. It's clean up stuff. Handle things smaller individually at a time. All right, that was the only one that people emailed me. So does anybody, who else has a question on, you looked at the answers, who else has a question on these problems? It could be any sheet, 6.4, 6.6, 6.7. Anybody have something? You checked your answers on it? Or if you still have a question on the AP problem that we went through, we could answer questions on that too. 6.7, number 12. Okay, it's all about how much work you're putting into this. Okay, let's do 6.7, number 12. Here we go. All right. Okay, so now this is with calculator, and remember, the AP said probably it's the 4-function calculator is really all you're going to need. So they're probably not going to have those graphing calculators. Okay, you got a function f of x. G is the antiderivative of f. Okay, find g of 1. Okay, so right away, it's just the vocabulary. This is an integral. Antiderivative is an integral. The antiderivative of f. So if I integrate f of x, I should get g of x. That's what they mean by when g is the antiderivative of f. So I should get, in this case, fundamental theorem again. Can you think of a function whose derivative is f? If I was just integrating this would be g of x plus c. Now, that's not the problem, but that's what they mean by that. Let's make sure we understand the language there. If g is the antiderivative of f, then when I integrate f, I get g plus c. Now, they're not asking for a plus c, they're asking for a value. They're wanting g of 1. So now, for this problem, we should integrate f of x with a bounds. And the bounds we should pick are 1 and 3. Smaller number on the bottom, bigger number on top. Because, here's fundamental theorem again, that's g of 3 minus g of 1. Now, let's make sure, Hunter, your question. So did you see, it's this, remember, content versus concept. Okay, the question is telling us this statement. That's translating the English to math. The question is telling us this statement. So now, how do you do the problem? Since we want values, we should have bounds on that. Take a look at that. Does that make sense? Because now it should be pretty straightforward. I use the calculator to evaluate this. Square root of x, is that cubed? Hold on, gotta enlarge it. X cubed, yes. Square root of x cubed plus 2 dx is g of 3 minus g of 1. We're looking for g of 1. We know g of 3. They told us that was 5. So I use the calculator for this. That's 5. Move stuff over to get the answer. Okay, but the key is what's the question saying? If f is the antiderivative of g, that's the statement. So maybe in words in your binder, this in English, this is f is the antiderivative of g. This is what this statement, when they say that statement in English, that's what it means in math. Okay? Eric wanted to go to, let's go to 6.4. 6.4. Number 4. All right, let's look at number 4. All right. We have water is being pumped into an underground tank at a constant rate. So remember rates, units, units, units. I could see a word problem showing up. Water is being pumped into the tank at a constant rate. So this is like one of those bathtub type problems. Water coming in, water going out. Okay, so the rate in is 8, and I'll just use the units gallons per minute. Okay, that's the rate in. In is gallons per minute. Out is a function. Out is the square root of t plus 1. Gallons, again, gallons per minute. That's a function. Okay? It says at time 0, there's 30 gallons, the initial condition, right? When t equals 0, gallons equals 30. How's that? First of all, can everybody get that information from the problem? Eric, your question, did you get all that stuff? We'll do the problem here in a second. At what time t is you have the maximum amount in the tank? We want to see when is there the maximum amount in the tank. Okay? So, how do we find out? Think of your bathtub. You got coming in, you got going out. If in is bigger than out, then the water level's rising. If leaking is bigger than coming in, the water level is falling. You see that? So maximum's going to occur, or minimums are going to occur when these are equal to each other. So the first thing I'm going to do is I'm going to see when 8 is equal to square root of t plus 1. You see that? That's the first thing I'm going to see. I'm going to see when they're equal to each other. So I square both sides. So they're equal to each other when t is equal to 63. And since now we check our domain, 0 to, so I make my number line. Here's from 0 to 120, and 63 is right there in the middle. All right, so let's see what's going on. Before 63, I'm going to pick a nice number. Let me pick 15. 15. Okay, before 63, in is still 8 gallons per minute. Out, if I pick 15, out is square root of 15 plus what? Square root of 16, out is 4. In, out is 4. So what's happening? the water level's rising. Okay, so in is 8, out is 4 at 15, so this is the water level is increasing. Well, think about if the water level's falling. Eric asks, why does a minimum mean that they're equal to each other? Is that like min and max? Min and max, think about it. If the water level's falling, so that means the water level going out is more than the water level coming in. Okay, when the water level going in and the water level going out are the same, it's flat, it's constant, it's not changing. Okay, so let's say the water level is going out faster, the water level's falling. Okay, so the amount of water going out is bigger than the amount of level coming in, the water level's falling. Well, now when the water coming in is bigger than the water going out, the water level's rising. So when they're equal to each other, that could be a min or a max, depending on which direction you're going in. Take a look at this one. Here, in is bigger than out, so the water level's rising. Here, let's look at this one. Let me pick a number over here on this side. Let me pick 99. If I pick 99, going out is square root of 100 is 10. So at 99, in is still 8, out is 10, so the water level is decreasing there. Well, if the water level is rising, the water level is decreasing, at some point the water level had to have been 0. Not changing at all. Did that make sense? Did I answer your question, Eric? Yeah, why does a minimum mean that they are equal to each other? Mins and maxes occur, if you have two rates, mins and maxes occur where things are the same. Okay, so now if I take a look at this and we do our little trick, right there, there's the maximum. At that time, it's a maximum. What's your justification? At t equals 63, the water level coming in and the water level going out are the same. Before 63, the water level was rising. After 63, the water level is falling. So 63 must be the point that we're looking for. Anybody else? How we feeling here? The answers are posted, and remember, you get points for checking if the answers are posted. But you've tried these problems, and is there any that you're still stuck on? That's all we're doing today. We're just seeing who has questions on stuff. Remember, it's all about how much you put the effort in. So you got to try these problems. And let's just pause and see if anybody's saying anything. 6.414. 6.4. We're on 6.4. 14. All right, so here, take a look at the picture here. 6.414, we got a graph here. Here's our picture of how the information is presented to us. And number 14 is all about the limit. We're taking a limit of something. Let me write out number 14 here. 14, it's the limit as x approaches 1 of 10 to the x minus 3 f prime of x all over f of x minus the arctangent of x. Okay? All right, so what's the first thing we do with any limit? We plug it in. Let's see what I got here. If I plug in 1, I have 10 to the first minus 3 times f prime of 1, f of 1 minus arctangent of 1. Now, luckily, we have a calculator here. So let's see. 10 to the first, that's easy. F prime of 1. Well, here's the graph of f. So what's the slope at 1? Remember, look at the graph. That's all how the information is being given to you. What's the slope at 1? The slope at 1 is 2. So on top, I have 10 minus 3 times 2. Remember, what's f prime? Oops, I slide it over. F prime is represented by the slope. Okay, so 10 minus 3 times 2. F of 1 is 1 minus the arctangent of 1. All right, ask yourself the question. the arctangent. The tangent of one angle is 1. And I'll use your calculator. Hopefully you're saying pi over 4. The tangent of pi over 4 is 1. Think about it. Opposite adjacent hypotenuse. So evaluating this limit on top, let's see what we got on top. We got 10 minus 6. We got 4 on top. On the bottom, we got 1 minus pi over 4. Maybe we get a common denominator on the bottom. 4. Okay, so we got 4. Maybe just match up with the answer. Divided by 4 minus pi over 4. Flip it over. 4 over 1 times 4 over 4 minus pi. Maybe they have 16 over 4 minus pi as the answer choice, just the algebra involved in there. But remember, the calculus is I'm trying to evaluate a limit. The first thing I do with any limit is I plug it in and see what happens. If I get 0 over 0, like we were doing yesterday or 2 days ago, we're talking L'Hopital's rule right there, if I get 0 over 0. Okay, so I plug in, and let's see what happens. And where do I get this information from? I get this information from the graph that was given to me. And what represents the slope? Or, I'm sorry, what represents f prime is the slopes. Straight line, that's kind of easy. Watch the scale. Hunter, that answer your question? Everybody okay on the rest of these? Anybody? How are we feeling here? Anybody? Don't be shy. Anybody have another question? While you're thinking about that, let's just review again next week. Remember, Monday is no school. It's an institute day. Tuesday, Wednesday, Thursday, Friday. Maybe we'll do, at this time, maybe we'll post an AP problem. I kind of like, I found a few of those. So we'll try a few of those to see how we do. Post an AP problem at 8:30. Give you what's a set amount of time to do it, and then we'll get back together and we'll do it at and we'll go over the answers. Maybe we'll do that for the next couple weeks. We'll see. I want to make sure we have something to do every day, and you're supposed to be here at 8:30 anyway. So let's do it that way. All right. What do we see? Number 4. Let's go to 6.7, number 4 and 5. Let's take a look at number 4. Oh, 6.6, number 4. Okay, let's do 6.7 while I'm here. Number 5. 6.7, number 5. All right. Let's see the information that was given. We got a graph here. We're given this graph here. And it says the function and blah, blah, blah. The graph has a derivative. Okay. Line segments as shown. Find the absolute minimum of f. Okay. Here's the graph of, remember, what's given the graph? This is the graph of f prime. We want to find the absolute minimum of f. How do we find a minimum? Okay, if I want to find a minimum, I've got to take the derivative. Oh, look, they gave me the derivative. So to find mins and maxes, the first thing I find is where f prime is equal to 0 or undefined. Now remember, just because there's a corner here at 1, that doesn't mean f prime is undefined. This is the graph of f prime. There's a point right here at 1. At 1, f prime is 0. Okay, so there's nowhere, I'm looking at this graph. This graph has no undefined, so there's nowhere where f prime is undefined. Well, f prime is 0. Let me make my number line. F prime is 0 at -5, at -3, at 1, and at 4. And let's check the endpoints. Was it open circle or closed circle? Closed circle, so we got to test the endpoints as well. Okay, so there is all possible minimums and maximums. You see that? Okay, so now let's test it out. What's going on between -5 and -3? The derivative is positive. Between -3 and 1, the derivative is negative. Between 1 and 4, the derivative is positive. Between 4 and 5, the derivative is negative. So we had our little trick. Goes up, down, up, down. Okay, so the maximums, or absolute minimums, minimums, which one of these are minimums? Well, -5 is a minimum, possible. 1's a possible minimum, and 5 is a possible minimum. See, if you look, those are the bottoms of our little trick here. Okay, so all we have to do is find f of negative 5, f of 1, and f of positive 5 to see which one's the smallest value. Because that's what they're asking for. They're asking for what's the absolute minimums. These are all relative minimums, but we want to find the absolute minimums. So how are we going to find f? We're given, now here's what you got to think. We're given f prime, the graph in this case, and we want f. What do we have to do? Now, they said f of 1 is equal to 3. That's kind of nice. We're given f prime, and we want f. What do we got to do? We got to integrate. Get from f prime to f. So our first integral is going to be from, I'll do from negative 5 to 1 of f prime of x dx. And here's fundamental theorem again, is f of 1 minus f of negative 5. Why did I pick 1? Because I know 1. And my other integral is going to be the integral from 1 to 5 of f prime of x dx is equal to f of 5 minus f of 1. You see what I mean? Because I mean 1's in both of them because they just told me f of 1 was equal to 3. How are we going to integrate from negative 1? Let's look at the graph. From negative 5 to 1, what do we got there? Known geometric. We got circles. From negative 5 to 3, the circle has a radius of 1. So it's half a circle, so it's pi over 2. And then from negative 3 to 1, the radius is 2. So pi r squared, so 4 pi, but half of it, so it's 2 pi. What do we got to remember about that? That's below the x-axis, so it's minus. Equals 3 minus f of negative 5. See how I found that? They're circles, and which we've got to remember what's below the axis, and this other thing, we've got to remember smaller to bigger. Let's look at this one, from 1 to 5. All right, what do we got from 1 to 5? We've got a triangle, okay, base of 3, height of 2. So that area of the triangle is 3. It's above the x-axis, so I put a plus there. Now we got another little triangle, base of 1, height of 1, 1/2, but it's below the x-axis, so I put a minus. Is equal to f of 5 minus 3 again. You see that? So f of 5 is equal to, let's slide that over there. We got 6, so 5.5. Oh, give me a decimal for this one. Where'd my calculator go? I lost my calculator. It's over here. We got pi divided by 2 minus 2 pi, some negative decimal, minus 3. So we got negative 7, but there's a negative in front. So f of negative 5 is equal to positive 7.7. Okay, so of these, let's put it in here. F of negative 5 is 7.7. F of 5 is 5.5. Which one is the absolute minimum? There's the absolute minimum because that's the smallest value. Now remember your justification. Your justification is these are all possible minimums. You say that. And then find the smallest value. You get the smallest value there. All right. How about, Hunter said we want to go to 6.6. 6.6, number 4. Let's go to 6.6. 6.6, number 4. Let's find number 4. Where's number 4? 3, 4. Okay, again, same situation. We're given a graph. What's the meaning of the integral of velocity? But it has the absolute value around it. Okay? The integral of velocity, but it has the absolute value around it. So what are we talking there when we talk an absolute value? You got to know that one. What are we talking when we say absolute value? We're talking distance, not displacement. That's the distance. So what does that integral mean? That is the total distance traveled. What's the units? Look at the words. The total distance traveled in total distance traveled in miles. Okay, the total miles traveled of, what's his name? Karan. The total distance traveled on his trip from 0 minutes to 12 minutes, the time it takes for him to go to school. So that's, first of all, the definition. Make sure you get all 5 things. You should be looking at your rule on all 5 things up there. What are the things you're supposed to say? We said the time. Between 0 minutes and 12 minutes, or the time it takes him to go to school, however you want it. This represents the total distance traveled. Remember, absolute value of velocity is distance. Okay, we would like to find the value of that. Okay, how do we find the value of that? Well, we're given the velocity. Okay, now here's a good example. Okay, we're not doing 12. How are we going to evaluate this function? How are we going to evaluate that function? We have the graph of that. We have the graph of regular. So the thing you got to remember about absolute value is there's no negatives. So even if you're looking at that graph and you're going, well, between 0 and 2, it's positive. So between 0 and 2, base of 2, height of 2, we got 2. And then between 2 and 4, we have 2 also. But remember, absolute value. So there's no negatives. We're not dealing with any negatives. And then we keep going. We keep adding up these things. Let's see, what do we got next? We got a triangle from 5 to 6, base of 1, height of 3. Then we got a rectangle for the next one, so another plus 3. You see, I'm just keep adding up. Here's a little trapezoid. Okay. Oh, and then remember the point. Oh, I should use the points. I'm looking at the scale here. Base of 2, height of 0.2. So I should have my points here. And this is point distance. This is 3, so 0.3. Right, it goes all the way up to 0.3. So 3 over 2.15, 0.3, since it's decimals. Okay, and then we're going from, you got the idea. We just keep adding up those areas together, and that is the total distance. So velocity, if it's just velocity, it's displacement. Okay, where it started, where it ended. Okay, but integrating absolute value of velocity is distance. You should be looking at your distance and displacement in your binder right now. Hunter, did that make sense? While you're thinking of that, Eric said, let's go over 6.4, 12, and 13. Okay, 12 and 13 there. Remember, if it doesn't make sense, don't say yes, it makes sense. Just let me know. We'll keep going over it. We'll keep talking about it. Is this, Eric, is that 12 and 13 or number 13? Let's do them both. This is fun. Just 13. Okay, let's do 13. All right, what do I see? I see a limit. What's the first thing I do with any limit? I plug it in. Okay, I got the limit. Let me write it out here. This is 13. I got the limit as h approaches 0 of the integral from x. Is that x? Oh, I got to enlarge that. Integral from a to a plus h f prime of x dx. And on the bottom, I have just, since I see the fraction one, I have h. You see how they got the fraction up there. Oh, what happens when I plug in 0? Okay, when I plug in 0, I get, is that? I plug in 0 for h, not for a. For h, I get 0, because a to a, remember h is 0. I get 0 over 0. So I should be thinking right there, I should be thinking that this is L'Hopital's rule, 0 over 0. But I could also think of, we're talking a derivative here. Okay, let's evaluate this. Okay, L'Hopital's rule will work, but I want to show you a little limit as h approaches 0. What if I just evaluated that integral right there? Who cares about the limit? Let's just evaluate that integral. Can I think of a function whose derivative is f prime? Yes, I can. Capital F. So on top, it's capital F of a plus h minus capital F of a, all over h. You see that? I should be thinking like that. I should be thinking, all right, what is that? What can I evaluate that integral right there? So now, this you should recognize. Okay, take a look at that. What is the limit as h approaches 0 of this thing? You should look at that, and that's the definition of the derivative at a. You see that? You should recognize this as a limit of some function with a plus h inside. Look at your definition of derivative. Remember, it was just lowercase f of x plus h minus f of x all over h. They're using h to give you a hint. That is the definition. This is f. I want to take the derivative of capital F, f prime, but it's not an x, it's at a. That is f prime of a. So the answer is E. You see that? Did that make sense? Eric, yes? No? Everybody follow that? So I evaluated this integral, and that integral became that. Right? Fundamental theorem. Can I think of a function's derivative as f prime? Yes, I can. Capital F. So this is f of a plus h minus f of x. Now, there's nothing I could say here. You have to recognize that as the derivative. You got to look at that and say, okay, that's a derivative. What's that the derivative of? That says take the derivative of f, so I took the derivative of f, but this time, if it was an x there, then I'm plugging it's f prime of x. But if it's an a, f prime of a. All right, good. A lot of people asked some questions. That's good. Going over this. Now remember what you got to do. You have to post your answers. You have to post your problem answers right here. Turn in the problems. See? Turn in the problems right there. Turn in each set so that I can see who's turned stuff in. Now, if you did it on AP Central, fine. But it was a lot of work there. If you did it on AP Central, or you can just email me. I don't care what you do. I'm going to do grades this weekend. Look at your grades. If you're like, wait a minute, Mr. No, you missed something. I turned it in. Fine. Just point it out to me, and I'll put it back up there and turn it in. And then next week, maybe we'll do only a couple, maybe one or two. I'll find another section. We'll do one or two of the problem sets, and then we'll do also on the days, we'll do an AP problem. We'll post it up maybe at 8:30, and then I'll send an email in the Schoology on how we're going to do that. But remember, no school on Monday, and then Tuesday, Wednesday, Thursday, Friday of next week. So it's 4 days. We'll be working on some more. And like I said, just practice some more AP problems. If you weren't here for that AP problem, take a look. Okay, take a look. It's posted right here, e-learning, practice AP questions. And I have the question that we did and the answer. So you should try that. That's a good review, a good practice of these. I can't force you to do it. I'm not going to come and kick you out of your bed because you're sleeping 12, 15 hours a day. I don't want you to do that. Make sure you be working on this stuff. Okay? And good luck with everybody. I will have a good weekend, and I will see you Tuesday, 8:30. Tell your friends. Everybody be here.